So we have a stone thrown horizontally from the top of a 27-meter tall tower, hits the ground at a point 11 meters from the base of the tower. Question asked, find the speed at which the stone was thrown. All right, so let's draw a little picture of what this situation looks like. I've got a tower, 27 meters tall. The stone is thrown horizontally, which means we throw it straight out, all right? And it follows some path, hits the ground over here, 11 meters from the tower, all right? And we need to find what this initial speed is up here, okay? Now, the way we're going to do this is we're going to break it up into two pieces. The part that's going up and down, and the part that's going in the x direction, all right? So let's fill in over here the things that we know and the things that we don't know. Okay, v0y, well, that's the initial component of the velocity in the y direction. That's the up, down. We said we throw it horizontally, so that's going to be 0. This, we don't know. We don't know what its final velocity is here when it hits the ground, but we'll figure that out later. y0 is the top of the tower. So that's 27 meters. The final position is down here at the bottom of the ground, so that's 0. Okay? Let's think about the x. Well, v0x, that's the thing that we want to find for the first part of the problem. Okay? Vx, that's the final speed when it gets down here. And we remember one thing about projectile motion is that when you throw something, once you let go of it, the x component of the velocity doesn't change. So once we have this, we'll have this as well. Okay? x0 is its starting position in the x direction. We're going to go ahead and set that one equal to 0. And 11 meters is my final position for this. Okay? The other thing we don't know is the time. All right? And that time is useful on either side of the equation. All right? If I were to have the time, then I could figure out the x stuff. So I need to get the time from the y stuff. All right, so we need to find the appropriate equation for the motion in the y direction. All right, and think about what we know and need to know. Well, let's see. We know this, we know this. What we're trying to find out is the time. Okay, so this would be the appropriate equation for the first part of the problem. So as far as y motion is concerned, throwing the ball is the same as simply dropping the ball. All right? So we think about how long does it take for the ball to drop. All right? So we decided to use the equation y equal y0 plus v0yt minus 1/2 gt squared. Okay? This guy here is 0. This guy here is our 27 meters. I'll just write him, keep him like that for now. Our initial y velocity was 0, so I can ignore that. Minus 1/2 gt squared. Just rearrange this. Okay, y0 equal 1/2 gt squared. Solve it for the time. Time is equal to 2y0 over g square root. Okay, we plug in our numbers for that, and we get a value of 2.35 seconds. So now what we want to do is we want to use this number to find the speed over here. So we're going to use the x component of the velocity. All right. And what do we have? Well, the appropriate equation for that would be this equation right here. We're talking about position for a constant velocity. We know this, and we know this. So we can use our algebra to solve for the velocity. We see that what we're going to use is x equal x0 plus v0 xt. We know it, we know it, we know it. We can solve for that. Okay? So x, this guy is 0, v0 xt, v0x is x over t, as you might expect. All right? X was 11 meters. T was 2.35 seconds, giving us an initial speed in the x direction of 4.69 meters per second. So the next part asks us to find the speed of the stone just before it hits the ground. Now remember, for a projectile, this speed is made up of two components, an x component and a y component. So let me draw this arrow nice and big. Okay, that's my total speed, but that is composed of a piece that's in the x direction and a piece that's in the y direction. The x direction piece we know from the last part of the problem. That's our 4.69 meters per second. I filled it in our table of things we know and don't know. All right? So if I know this, I need to find this. Okay? How do I find that? Well, let's look at our y equations again, or I should say the things we know about y. We now have the time, all right? And we're going to go ahead back to our toolbox and look at the y equation. So what we need now is we need the y velocity for the stone after it's thrown off the tower. What do we know? Well, in this equation, this is what we want to know. We know this, and we know this. So that's the right equation. Coming back, we've decided then to use Vy equal V0y minus gt. Okay? Knowing our initial is 0, I just have this. So I have minus gt, or minus 9.8 meters per second squared times 2.35 seconds, giving my Vy of 23 meters per second. All right, so now I've got a component, I've got the two components. Oh, I should say this is negative because it's pointing down, but we're gonna just worry about speed here. So let's see how that works out. All right, so how do I find my total speed? Remember we use this Pythagorean theorem thingy, all right, where I take Vx squared plus Vy squared square root. Okay? Plugging in our numbers from the two parts of the problem, 4.69 meters per second squared plus 23 meters per second square it and take the square root. All right? When you get done with that, what you end up with is 23.5 meters per second.